So what are a couple of things you learned about I in the last couple of days? It's an imaginary number. That's great. What's another thing? Yes. It equals the square root of -1. Those are two great cases. What you got, Jacob? Yes, we were able to pull it out when the square root has a negative. That's perfect. And then you can just treat it as a positive number inside. Love it, Jacob. Any others? Those are all three great examples. You need to write two. You could have also written something along the lines of I squared equaled -1. Two imaginary numbers multiplied to an actual real number. But any fact like that would have been just fine. All right, so let's get into our spiral notes then. All right, so make sure I don't forget things. So let's do a little bit review. So this right here, again, will be lesson 5. An appearance of complex numbers. So it's a continuation of lesson 4. All right, so some review. Give me some examples of what a real number looks like. Awesome. Any others? 3. Any others? Okay, can I get something that's not a whole number that might be real as well? -1. Any others? Is decimal real? 0. Good. 0 is a real number. What was another one you were about to say? 1.5 decimals are real numbers. Is this a real number? Yes, it's a real number. So any number that can basically be expressed with numbers is a real number, right? Even fractions. Give me an example of a fraction. 3/4. Very good. Decimals, fractions, all whole numbers, 0, all are examples of real numbers. Give me an example of an imaginary number. All right. Can you give me another example? No. No. What's another imaginary number? So this is technically what you would say when you say I, that's like one I. Can you give me another imaginary number? That end up being real. Would you guess that this is also imaginary? If I said 3i? Yeah. Would you say that maybe I square rooted 2 is also imaginary? Right? Because this would typically be the square root of -2, and then we would pull the negative out to make it I, just like Jacob said earlier today. So those are just different examples of imaginary numbers. Basically, if it has an I in it, it is imaginary. Then we learned this thing called complex numbers, which we saw was in the form of A plus BI. What was the A part? What did the A part represent? Okay, let's ask this question. What's the BI part represent? Imaginary. So anything with an I makes it an imaginary. So therefore, the A is the real part. So to make it, so you have real numbers, you have imaginary numbers, and to make it complex, it's a real plus an imaginary. So it's when we combine the two. Can you give me an example of a complex number? Awesome. Can anyone give me another one? 2 plus. Awesome. Does it have to be a square root? No, it could have been like, it could have been this as well. We could have had, and it doesn't have to be a plus. It could have been 2 minus 3i or something like that, right? Because when you are subtracting, if you don't know this already, it's adding a negative number. So it's still adding. It's still got that A plus BI format. It just means you're adding a negative number when you are subtracting. So any questions on what real, imaginary, or complex numbers look like? All righty. So when we are graphing this, and I talked about this when we talked about the imaginary part, the x-axis represented what? on a complex number. They're real. So this was our real axis. And then the y-axis represented my what? Imaginary part. So I say this, I didn't go too much into detail other than what I squared, I cubed, and all those different i's look like. But if I wanted you to graph 5 plus 2i, you would start with your real part, which is 5. So I'm going to go 1, 2, 3, 4, 5 on the real axis. And then I'm going to use the number in front of the I to represent my imaginary part. So that means I would then go up 1, 2. So therefore, this is what 5 plus 2i would be graphed on a complex plane. And it's That's it. That's all it is. So reality, what I need you to see, even though this is 5 plus 2i, we can represent this as just a regular coordinate on a complex plane. If this was just a regular coordinate plane, how would you write that as a coordinate? In this case, it'll just be the 2. So, and that's all you have to do. So if I give you a complex number and I ask you to graph it, you graph it as if it was a regular coordinate 5 comma 2. And that's what that would be. Any questions on that? And it's just that easy. That's done. You're going to like it today. So with that being said, if we jump back to our workbook, right below the opening exercise has a visualization. So you can see this is what a complex plane looks like. 1, 2, 3, 4, 5 to represent my real part. I, 2i, 3i, 4i, 5i to represent my imaginary part. And it does the same thing as our regular coordinate plane. If I go to the left, it's the negative real numbers. If I go down, it's the negative imaginary numbers. So if, again, I wanted to, let's go with 2. Oh, I need to be able to write. Let's say I go with 2 minus 3i. Let's say I wanted you to graph 2 minus 3i. What is the coordinate? And then you would just graph that. So I would go over 1, 2, and then down 3. There is your coordinate. Yes, yeah, that's what you would put in that thing. So you have a note. What you'll see in here is they'll give this a name. They'll get all kinds of different names, but the biggest one you'll see is W. And the reason they're going to give it a name so that when you graph it, all I have to do is put a W next to my coordinate rather than having to write out 2 minus 3i or write 2 comma negative 3. Because what you're going to do today and tomorrow is you're going to graph a lot of them. And so if we easily just attach a W to it, I can see W represents that. A Z might be up here, represents a different complex. A Y might be somewhere here. And this makes it easy to label. Maybe we use ABC. Questions on graphing? So you can use this as a sketch. It's all for you to work out different things. So any questions on graphing? That's about it on that part. And so you'll have lots of examples today and tomorrow when we get to that point to try that out. Let me go back to our whiteboard. So the other things you got to learn here, well, I'll tell you what, let's take a pause. And I want you to answer 1 through 3 on your exercise. So if you flip to the next page of your workbook, go ahead and answer the first 3 questions. Everyone done with the first three questions? So number one, just give me an example of all three. We did that at the beginning of this lecture. Number two, tell me what each axis represents, the vertical and the horizontal. We went over that at the beginning of the lecture. So this is actually just adding and organizing your information. And then number three, what is that as a coordinate? Perfect. Make sure you use parentheses around that to represent a coordinate as well. That's very important because starting starting Friday, our parentheses will turn into what they look like inequality symbols to represent something due. So when we're doing coordinates versus what we'll learn about vectors, the notation matters. So any questions on the first three? All right, still keeping it pretty easy. Like it so far? So now we're just going to do some arithmetics. All right. So in the first, next thing I got to teach is the scalar multiplication of complex numbers. And literally that just means you're going to have some number outside of the parentheses of a complex number in which you would have to multiply everything inside. So if I had to work this out, what would I do? And how do you just get that? You just distribute. That is what scalar multiplication looks like. So you would literally go 9 times -8, which is -72, 9 times 10, which is 90i. Yes, these are part of your notes. Sorry. Questions on how to do a scalar multiple. If you like to see it as a property, it looks just like this. So if I had, let's do a different letter than A. Let's do a C, and we'll do A plus BI. So if this is my scalar multiplication property, this will just mean that this is A times C plus B times C I. Right? So basically you're just taking whatever the scalar is and you're multiplying it to the real part and the imaginary part. Okay. Questions on that? All right. So in the next part, what will be presented to you is I will say, I'll give a complex number a name, and I'll say W is equal to 3 plus I. And then I'll follow up with what is 2W. So if I'm looking for 2W, what do you think I'm going to do with that complex number? Scalar multiplication, in which I do what with the 2? Distribute it, and that's it. So when I ask for 2W, this is how it'll look. I'll just write 2. I'll replace W with what it's actually equal to. And then I'll work it out. 2 times 3 is 6. 2 times I is 2I. Right? Questions on how to do scalar multiple. The next task it's going to ask you to do is to graph both the original W and the new 2W that you just solved for. So I'm going to try my best with the graph here. You'll have graphs, I think, on your assignments. Let's pretend these are nice straight lines. If I wanted to graph W, what is W's coordinate? No, not 2W. What is W's coordinate? 3, 1. If there's not a number there, just like in any other quadratics that we dealt with, there's an imaginary 1 there. So this will then become 3, 1. So I'll come over here and I'll do a rough graph. And then I label it W. I don't have to write out 3 plus I. It had a name. I can just write that letter and move on. How would 2W's coordinate look like? 6, 2. Again, notice I'm putting parentheses around that. So I'm going to go 1, 2, 3, 2. And then notice if I had, let's put some lines in there, give you a little bit of visual aid. If this was my original direction of it, is this roughly doubled? Yeah. So it's roughly doubled. And it kind of does the same thing. If I was to multiply it by 3, then it would have tripled it and quadrupled and so on and so on. So graphically, you can see as I graph it is being doubled. Any questions on scalar multiplication or graphing it? Alrighty. So the next part then is just simply multiplying complex numbers. So we will multiply complex numbers. Out of all the different operations, this is probably the hardest in the sense that there's probably more work to do than the rest. What does it mean? It is hard, right? It is the hardest, but not hard. So if I gave you this example here, and I said multiply 8 plus 7i times 10 minus 5i. When you look at this, how do you think you would multiply this out? That's exactly right. I heard the word FOIL earlier as well. That's exactly how you work these things out. So let's do that. So 8 times 10, 80. 8 times negative 5i, 7i times 10, 7i times negative 5i. Ooh, just negative 35i squared, because it's an I times an I. Now here's a couple of things we're going to do in this next step. What do you first notice? And what would you do to try to condense this? Oh, you could, but in this situation, we want to keep it as a complex form. So you always want the real plus then the imaginary. But what would you do in this case if you were asked to simplify that? Combine like terms. Let's go ahead and combine the negative 40 and the 70i. So I'm going to drop down the 80. What is negative 40i plus 70i? Negative 30i. Very good. Oh, my bad. You're right. Positive. My bad. Positive 30i. I did that on purpose to make sure you are paying attention. Good job, guys. Good job. Ooh, so close. Positive or negative? Positive. So what happens here, and I'm going to write this step out, but if you went to the next step, I'll be totally okay with that. But I squared, just like Jacob said, is equal to negative 1. So this now becomes negative 35 times negative 1. And what's two negatives going to make? A positive. So now we have 80 plus 30i plus 35. What can I do now? So what is 80 plus 35? 115 plus 30i. This part, no. If you went from negative 35i squared to positive 35, I completely saw what you just did there. I wrote it up so you could see, because a lot of times when I skip this step, students ask me, well, what happened to the I squared? The I squared turned into a negative 1. What would it then become? A negative 35. It would change the sign of it. So if this was a plus 35i squared, it would then become a negative 35. And then again, notice how I wrote the answer. I wrote the real part first, then the imaginary. This is how it has to be done. Even though technically 30i plus 115 is the same, it is not in its correct complex number form. So don't lose a point just because you wrote it backwards. Questions on how to do a multiplying complex number. All right. Let's see if it goes any further. All right, so let's do the next part, which is the last part I have today, and then you'll work on the exercises. So in example 3 here, oh man, that's a bad E. Let's try that again. So in example 3, is the addition and subtraction of complex numbers. Addition is the easiest thing to do, and I'll show you an example here. So in this example, oh, let's not use that symbol. In this example here, let's look at negative 10 minus 3i plus -6 plus 6i. When you are literally adding, what do you think I'm going to do here? Add what? Like terms. Perfect. I'm literally going to come over here. Let's change a different color. And I'm going to add the real parts because those are like. So what's -10 plus -6? -16. And then I'm going to add the imaginary part. So what's -3i plus 6i plus 3i? Here's the biggest mistake I see students make. If you get a positive answer, don't forget to write a plus sign there. A lot of kids will just write it as -16 3i and totally miss out on that plus sign. But yes, that's it. All right. Subtraction is the same concept. So let's look at it, but this is the most missed. But 9 minus 6i minus -3 minus 10i. Here is my recommendation so you don't make the mistake. When you get good at your subtraction, you can do the same thing and say 9 minus -3 and work it out. But a lot of my students get confused and only apply it to the first one. You have to apply it to both. So I would actually rewrite this as 9 minus 6i, no parentheses needed. A negative times a -3 becomes what? This then becomes a plus 3. And then a negative times a -10i becomes a what? Plus 10i. Now you've turned it into an addition problem. How would I work this out? Combine like terms. What's 9 plus 3? And what's -6i plus 10i? Plus 4i. Right? Addition, you can go straight to combining, but with subtraction, make sure you distribute that negative so that you actually do the correct process. Or if you could see that this is 9 minus a negative, which makes a positive, and do that process, that's great. I just don't want you to make a mistake there. Any questions? I literally think that's it. So now work out the examples 4, 5, 6, and 7. And that's the end of what I got.